Dear Science Whiz viewers, welcome you all to another session. Hope you all have watched part 1. Here is a part 2, class 10, chemistry part, chapter 4, carbon and its compounds. Let's start with a quote, think like a proton and stay positive. In today's session, we are going to learn two types of chemical bond, ionic bond and covalent bond, its bonding structure, with examples and a questionnaire related to it. Please like, share and subscribe. If you have already subscribed, please click notification button to notify future videos. Let's move on to the chapter. Let's meet 4 friends: sodium, chlorine, carbon, hydrogen. So, sodium and chlorine, ionic bond, chlorine. How can I get 1 electron to complete the octet of 8 electrons in the valence electron shell? Sodium. I can transfer my electron to you, my friend. Here, the ionic bond forms when a metal atom transfers 1 or more electrons to a non-metal atom. Ionic bond consists of the bonding between a metal and a non-metal. Here, the metal loses electrons to become a positively charged ion, and the non-metal gains these electrons to form a negatively charged ion, which you are going to learn in the next slides. Here we can see sodium, which is a metal, and chlorine, a non-metal. To show their bond, sodium gives up 1 electron to chlorine. This completes the octet of 8 electrons in the valence electron shell. Next, carbon, hydrogen. Carbon, I need a friend who can share electrons with me. Hydrogen, don't worry, we can share each other. Here is a covalent bond. A covalent bond involves the sharing of electron pairs between atoms. Covalent bonds are formed between 2 nonmetals. Covalent bond can be either polar or non-polar. In this case, carbon and hydrogen form a covalent bond by sharing their electrons together and form methane. Carbon shares total 4 electrons, 1 with each hydrogen, and all 4 hydrogen share their 1 electron each with carbon and form methane, CH4. Methane is a covalent compound containing covalent bond. Let's learn in detail about covalent and ionic bond. Two main types of chemical bonds, ionic bonds and covalent bonds. An ionic bond is a bond formed by the strong force of attraction between 2 oppositely charged ions. Here, a metal and a non-metal is involved. As you can observe, sodium atom has 1 electron in its valence shell. It loses 1 electron to chlorine to form octet configuration. What is octet configuration? According to octet rule, it refers to tendency of an atom to prefer to have 8 electrons in the valence shell. Whereas chlorine has 7 electrons in its valence shell. It gains 1 electron from sodium atom to achieve octet configuration and form anion chlorine negative. Here, the electrons get transferred from sodium to chlorine atom and form their respective ions. Sodium forms cation Na plus and chlorine forms anion chlorine negative. Here, the electrostatic force of attraction holds the oppositely charged ions together by an ionic bond and form the compound NaCl. What's the difference between ionic bond and the covalent bond? The main difference between the ionic bond and covalent bond is that here the transfer of electrons takes place and here sharing of electrons takes place. An ionic bond is between a metal and a non-metal. Here the non-metal attracts the electron, so it's like the metal donates the electron, for example sodium chloride. Whereas here the bond between the non-metals with similar electronegativities. Here atoms share electrons in the outer orbitals. For example methane, CH4. Covalent bonds are of two types, polar covalent bond as well as non-polar covalent bonds. Covalent bonds, the sharing of electrons. To explain this type of bonding, let us consider a simple molecule, that of chlorine gas. Each atom of chlorine has 7 electrons in its outermost shell. Hence, its electronic configuration is 287, which means it is 1 electron short of the stable octet in the third shell. It achieves stability by sharing 1 electron with another chlorine atom, which in turn shares one of its electrons. This shared pair of electrons forms a single covalent bond. Let us consider oxygen molecule. Each atom of oxygen has 6 electrons in its outermost shell. Its electronic configuration is 286, which means it is 2 electrons short for the stable octet. It achieves stability by sharing 2 electrons of another oxygen atom, which in turn shares 2 of its electrons. As a total of 4 electrons, that means 2 pairs of electrons are shared by the 2 oxygen atoms and they form a double covalent bond. Next, let's learn about nitrogen molecule. Each nitrogen atom has 5 electrons in its outermost shell. So how many electrons does each nitrogen atom need to fulfill octet rule? So nitrogen 2, 5, that is electronic configuration. So it needs 3 more electrons to complete the octet rule. So here sharing of 3 electrons takes place and form triple bond. Nitrogen atom has 5 electrons in its outer shell. 2 nitrogen atom each will share 3 electrons to form tricovalent bond and makes a nitrogen molecule. As you know, each electron pair is one bond. Nitrogen has 3 bonds between its atom. Hence, it's called a triple bond. Next is the formation of covalent bond in ammonia molecule. Nitrogen atom, it has 5 electrons, electronic configuration 2, 5, in the outermost shell. It shares 1 electron to each of 3 hydrogen atoms to form ammonia molecule. Here, one unshared pair of electrons in ammonia molecule is not involved in bond formation and it's called as a lone pair of electrons. Formation of covalent bond in carbon tetrachloride. Carbon atom has 4 electrons in the outermost shell. In the formation of carbon tetrachloride, it shares 4 electrons with 1 electron each of 4 chlorine atoms. In turn, 4 chlorine atoms share 1 electron each with 1 carbon atom. Thus, in all, 1 carbon atom and 4 chlorine atoms complete their octet by mutual sharing of electrons and carbon tetrachloride containing 4 covalent bond is formed. Let's summarize what we have learned. The atomic number of carbon is 6 and its electronic configuration is 2,4. To attain a noble gas configuration, it requires 4 more electrons in its valence shell. It's difficult for an atom of carbon to either gain or lose electrons, as it would be difficult to hold extra electrons and would require a large amount of energy to remove 4 electrons. So, carbon attains a noble gas configuration by sharing its valence electrons with other atoms. Such mutual sharing of electrons between atoms to attain a noble gas configuration, stable noble gas configuration, is called covalent bonding. Atoms of other elements like hydrogen, oxygen, nitrogen, chlorine also show sharing of valence electrons. Depending on the number of electron pairs shared, covalent bond is of 3 types: single covalent bond, double covalent bond, triple covalent bond. Single covalent bond. Single covalent bond is formed because of sharing of 2 electrons, that's 1 pair. Example, hydrogen, chlorine, methane. Next is double covalent bond. Double bond is formed by sharing of 4 electrons, that's 2 pairs of electrons. Example, oxygen molecule, carbon dioxide molecule. Next is triple covalent bond. Triple covalent bond is formed because of the sharing of 6 electrons, 3 pairs of electrons, that means. For example, nitrogen, C2H2, acetylene. Here are the physical properties of covalent bond. Boiling points as they have weak intermolecular force. They are generally poor conductor of electricity, as electrons are shared between atoms and no charged particles are formed. Versatile nature of carbon. The 2 characteristic properties of carbon element which led to the formation of large number of compounds. Catenation, tetravalency. Catenation. Carbon can link with carbon atoms by means of covalent bonds to form long chains, branch chains, and closed ring. Compound carbon atoms may be linked by single, double, or triple bonds. Next is tetravalency. Carbon has 4 valence electrons. Carbon can bond with 4 carbon atoms, monovalent atoms, oxygen, nitrogen, and sulfur. That's all in part 2. Part 3 will be uploaded soon. Thank you so much for your support. Please like, share, and subscribe for more videos. Which compound contains both ionic and covalent bonds? You are right, sodium nitrate, NaNO3. Under normal condition, fluorine is a gas and bromine is a liquid. This is because, any guess? Answer, fluorine has weaker intermolecular forces than bromine. Carbon dioxide is a polar or non-polar molecule? Right, it's a non-polar molecule. Next question. An atom of which element has the greatest attraction for electrons in a bond with hydrogen? The answer is none other than chlorine. Shape of ammonia. You are right. Answer is trigonal pyramidal. Next question. What happens when two chlorine atoms combine to form a molecule of chlorine? Answer. A bond is formed and energy is released. The self-linking ability of carbon is called? Answer. Catenation. The last question. Almost 95% of compounds are of carbon because they can form. Answer. Multiple bonds. Science Whiz. Test your knowledge.